let's do one last example of a mixture problem. And in this one, this is a type of problem you would often see in a chemistry class or a math class where we're looking for applications. But it's just another what we call mixture problem. Let's go ahead and read it and talk about how we get started. So let's say that you work in a chemistry stockroom and your instructor asks you to prepare 6 liters of 10% hydrochloric acid, which is a specific balance of solution where for certain experiments you want to have the right concentration. If it's not right, it's not necessarily going to work properly. Again, I'm not a chemistry teacher or a chemistry expert, but let's just assume we need that for whatever reason. But unfortunately, when you're looking in your stockroom, you can only find 8% and 14% solution there. But you can use those two solutions. You could imagine using the 8% to dilute the 14% or use the 14% to strengthen the 8%. But the question is, how should we make that balance? Like if we just use them both evenly, if we pour those two solutions together, it's not necessarily going to make the desired amount. But exactly how much of each should we mix together in order to form the proper concentration of the proper amount? And in the same way, goal number 1 is what are our equations going to look like? And I have put a little table here to help us extract the most important information. But remember that your choice of variables should typically be asked in the question itself. So it says how many liters of each solution should we mix together, implying that I want to know how many liters of the first bottle and how many liters of the second bottle am I using? Like, is it going to be 3 liters of each? Is it going to be 1 and 5? And also, we know how many total liters we need, which is 6. So as I'm reading this, I'm trying to focus on all of the information that is relevant. But basically, 6 liters is a key thing that I need. And also, another key is that I want to make sure that that 6 liters is a 10% solution. And actually what that implies is I know exactly how much hydrochloric acid is in that solution because it's just 10% of 6. But that's, we'll focus on each equation separately because, again, what we're going to end up with is 2 equations with 2 unknowns, and we're going to solve it in the same way. Another way that you know how to solve or how to begin working on a question is what chapter of the book is it in. If it's in the System of Equations book, they're probably expecting you to write a system of equations. On a test, you might not necessarily remember, okay, what chapter was this in? But anyways, you can often figure it out by just writing down all the information you have and trying to think about it. But in this case, I know I have 6 liters of solution. So like in a similar way as before, I know what I'm calling X is the number of liters of my 8% solution, excuse me. And Y is the number of liters of my 14% solution. And when I add those two amounts together, it's like I have some amount of liters in this bottle, I have some amount of liters in this bottle. Together they should make 6. X plus Y should be equal to 6. Kind of like with the quarters and dimes, when I'm mixing those quarters and dimes. It's a very similar structure to this example, which is why I wanted to start with that. But basically, when I mix those together, I'm going to get 6 liters of total new solution. But basically, this equation ensures that I have the right amount. I also want to make an equation that makes sure I have the proper concentration. Basically, that my answer does come out to 10%. But basically, what I know is the concentration of each bottle individually, and how that will work is, well, if I'm using X liters of the first solution, if it's an 8% solution, which it is because it told me that, I know exactly how much HCl is in that bottle because that's how concentrations work. If it's 8%, that means 8% of the total is that. So if I take 8% of X, that should tell me exactly how much hydrochloric acid is in the first bottle. And when I add that to the amount of hydrochloric acid in the second bottle, which is a 14% solution, together, those should give me a total amount of hydrochloric acid in the mixture combined. I also know that my total amount of hydrochloric acid, I want it to be 6 liters of a 10% solution. So since it's a 10% solution, and it's supposed to be 6 liters, I know that that's exactly 0.6 amount of hydrochloric acid of the liters. So basically 0.6 liters of hydrochloric acid is in that for a total of 6 liters. But basically this, you could call the yellow equation your hydrochloric acid equation. The first equation your total equation. And notice what I have is 2 equations, 2 unknowns. So let me go ahead and just rewrite that as 0.6. But that is just the percentage times the amount to get the total amount of acid. So now, again, it's a system of equations. We now need to solve it. So let's just go ahead and use substitution, but you could use either form because I know that x should be equal to 6 minus y. Whoops. And now that I know that, I could plug that in for x to solve for y, or vice versa. I could solve for y to plug in for x. So 0.08 times 6 minus y plus 0.14y is equal to 0.6. And now I just need to do some math to find y. So by distributive property, 6 times 8 is 48, so this would be 0.48 minus 0.08y plus 0.14y is equal to 0.6. If I multiply through by 100, I can get rid of all the decimals, so I'm just going to do that. I could have done that earlier, but doesn't matter. You don't necessarily need to do this. And if I multiply by 100, that would move 2 spaces, so that should not be 6, it should be 60. Now, combining like terms, I would get 48 plus 6y is equal to 60. Subtracting 48 would be 6y is equal to 12. And dividing through by 6 would leave me with y is equal to 2. And also, since I labeled my variables, well, that's a step that I kind of gave you, but this is what I would always recommend beginning is organizing the information. What are my bottles? What's my goal? How much of each? What are my variables mean? But X was the number of liters of bottle 1, and Y was the number of liters of bottle 2. So what this is implying is that I need 2 liters of 14% solution. And since X plus Y had to be 6, I also know that X is equal to 4, which implies that I need 4 liters of 8% solution. And regardless, in this case, it came out to be nice, pretty numbers. It wouldn't necessarily be so perfect at the end of the day. But what I can tell is I need more of the 8% solution than the 14%. And this kind of makes sense because if I'm trying to make a 10% solution, it's closer to this one than this one. So I want to use more of this because it's actually closer. And this one this one is a lot more diluted. Well, this one is a lot stronger compared to the dilution of this from 10%. So I need less of the stronger solution and more of the slightly weaker solution, if that makes sense. And of course, I could check by plugging it back into my original equations, assuming these made sense. In that, if I take 8% of 4 liters, that would give me 0.32. And if I took 14% of 2 liters, that would give me 0.28. So 0.32 plus 0.28 is 0.6. Yes, that adds up, and it's going to work. It's going to give me the proper concentration. And also, 2 plus 4, or 4 plus 2 is 6. We're good. It makes sense. And that is the answer to our mixture problem.